Hi guys, welcome back. We're going to continue on chapter 10. We are just going to have a video for today. So chapter 10.4, is surface areas of prisms and cylinders. So kind of how this chapter is going to go for a couple of the sections. We're going to do surface area of prisms and cylinders. Then we're going to do surface area of pyramids and cones. Then we're going to do volume of prisms and cylinders, and then volumes of cylinders and cones. And then we'll continue on with a couple more things. So just kind of an outline, but today we are going to do the surface area of prisms and cylinders. I'm going to read a little bit of this too because I think it's helpful. So we talked yesterday about a prism. It's a polyhedron with two congruent parallel faces called bases. The other ones are called lateral faces. So the ones on the sides are lateral faces. And then you can name it by the shape of its base. These are sitting on its base, but sometimes they're sitting sideways. So watch out for that. The altitude is the height. Notice here, this is still the height because it's sitting on its side. If you notice, these are the bases that are the same, that are parallel, and so it's just sitting sideways. It can be either right, meaning it's a right angle right here, or they call it oblique, where it's slanted a little bit. So in a right prism, the lateral faces are rectangles, and a lateral edge is an altitude. In an oblique, some or all of the lateral faces are not rectangular. So we are going to just do right prisms for now. So if they don't put the right angle in, you can assume it's a right prism for this book. Okay, so we're going to look at two things, lateral area and surface area. Lateral area is just the area of all the lateral sides or faces, whatever way you want to put it. This is a shortcut if you'd like, perimeter times height, but I just take all of the areas of the sides and add them all up. And then surface area is you take the lateral area, which was the area of all the lateral sides, and then you're going to add both bases. So there's the top base and the bottom base in a prism. And here they kind of wrote it out for you. So let's try a couple of these. This one is a triangular prism. Even though it's on its side, the triangle is still the base. It is parallel to the other triangle. So I'm going to need to find the area of this triangle. But before we do that, let's do lateral surface area. So I'll just abbreviate it. Lateral surface area is going to be all of the sides, so not including these two triangles. So the sides there would be this one, which is 10 times 24. And it is also going to be, let me match my colors. It is also going to be this light pink bottom one, which is 6 times 24. And make this dark pink. It's going to be this side one here, which is 24 times 10, or 10 times 24. Base times height is the area of those rectangles. So 10 times 24, I can add that all up in my calculator. 240 plus 144 plus 240. And that will give me 624 inches squared. So that is the lateral surface area. So all of the sides. Then if you want the actual surface area, you have to take the lateral surface area and you have to add the bases, the area of the bases. So I'm just going to take what I got from the last problem, 624, and then I'm going to need to find the area of these bases. I'll do this in purple. This one should be the exact same as this one. So I know this is a triangle, which has an area of a 1/2 times base times height. I didn't say this earlier, but the area of a rectangle I got over here was base times height, or length times width. But with our triangle, I don't actually know the height of my triangle, so I have to do a little bit of Pythagorean theorem. This would be 3 and 3. This would be x, and so I would do 3 squared plus x squared equals 10 squared off to the side. 9 plus x squared equals 100. Do a little bit of algebra. X squared equals 91. Square root both sides. And I'm just going to do this in decimal form. If you have questions about the ACT method, you can go ahead and do it that way. Let me know. But I'm just going to do this with decimals. So it is 9.54. I think I included both the ACT and the decimal way on the answer key for the homework. So then I would say the area of one triangle is 1/2 times 6 times 9.54. The area would then be 28.62. So I have 2 of those bases. When I add those in, and that will give me a total of 681.24 inches squared. So if you wanted to cover this shape with wrapping paper, that's how much you would need. Or think of it like those Toblerone candy bars, I think are this shape. So that is the wrapping that they would need to do that. Let's practice another one of these. See if you can do this on your own without me. If you want to pause the video and try it, you can go ahead and do that right now. If you want to follow along with me, that's fine. Or if you guys tried it already on your own by pausing the video, here is the answer. So you'll do the lateral area, which is all of the lateral sides. All areas, I guess. And it's looking like I have 4. This purple one, this reddish, pinkish one, the light pink or darker pink, and let's do neon green. Since the base is a square, these are all the same, but I'll go ahead and write them out separately. So we have, they're all rectangles, so base times height, 10 times 4 for the purple one. That dark pink one or reddish one was also 10 times 4. The pink was 10 times 4, and the green was 10 times 4. So that would be a lateral area of 40 plus 40 plus 40 plus 40, or the lateral area equals 160 feet squared. Whoa, is that what you got? Let's go ahead and add the top and the bottom for the surface area. So that's this square in orange. I'll just do them both in orange since they're the same. So surface area is just the lateral area plus the area of the bases, which are exactly the same. So this orange square is 4 times 4. And so that gives us 16 for the area of one base. So the surface area is just the lateral area, which is 160, plus one base, plus the second base. And that gives us 192 feet squared. I did that in my head. I'm just going to double check in my calculator. Yep, 192. So that is how you find the surface area of a prism. Some of the bases are going to be a little harder than a square or a triangle. I think there's some pentagons on there, hexagons, some things that you'll need to use. Some of those earlier things we learned in chapter 9. So You might need to find some more difficult areas of bases. So that is how to find the area, the surface area, the lateral area of a prism. Let's go on and do a cylinder. So a cylinder is kind of like a prism in that it doesn't come to a point. It still has these two bases, but it's curved on the side. So a cylinder is a solid that has two congruent bases that are circles. Don't forget the area of a circle is pi r squared. The altitude or the height is what connects those two circles. So this is like a canned good. You've got your canned good sitting straight up, or the height is still the height of the canned good, even if it's laying on its side. Again, we have right cylinders and oblique cylinders, and we're going to do the right cylinders for this book. So even if they don't put that little right angle in this book, they're saying you can assume if it looks straight, it is. So let's look at the formulas for these. The formula is still the same. You can say that the lateral area equals the area of the lateral sides, and the surface area is equal to the lateral area plus the area of the bases. So same as before, but they created a little bit of a shortcut. I want to show you how this works. If you take a canned good, and I wish I could show you in person, and I'm going to kind of rip the label right here and pull the label open. So this is still the height, but then that label will almost become rectangular when you open it up. So if you want, you can pull a canned good out, rip the label off. The height is still the height of the canned good, but this right here that I'm highlighting in orange, that is actually going to be it's basically the width or the length of that rectangle. So length times width. But that width is our height, and then our length is kind of still our length. But this is the circumference of the circle. So that length is circumference, which is 2 pi r. So that's where they get this formula, 2 pi r times the height. So if you would rather write lateral area, I'm going to switch colors, as it's still the area of the sides, but the area of the sides is length times width, and that length is the circumference. So some people write it circumference times height, or some people write it circumference, which is 2 pi r times height. Whatever works for you guys. And then since the bases are circles, and remember the area of that circle is pi r squared, once they're doing the surface area, they say it's still the lateral area, and then they just add on pi r squared twice. So once for the top and once for the bottom. So that's kind of the formula for a canned good. Where this is used is maybe if you need to figure out how much labeling you need, how much material you need for the canned good, or if you're looking at the surface area and you want the top and the bottom, you would be seeing how much aluminum you need for that canned good. So here's their kind of abbreviated version, 2 pi r times height, or pi times diameter times height, and then lateral surface area, they kind of wrote that out, what we did earlier here. So whichever one you like, you can use the one in green or the ones in pinkish, either will work. So let's do one of these. This is a canned good on its side. So this here is still the base of that canned good, even though it's on its side. So if we're going to find the lateral area, I'm going to need to do the area of the lateral sides, or in this case, circumference times height. Basically, when I have that rolled out label, it's going to be a rectangle, and then the circumference is like if you were doing length times width or base times height, circumference is like the base and height is the height. So circumference is 2 pi r, and then times the height. So if the diameter is 15, then that radius is just going to be 15 divided by 2. So if you want to do decimals, that's 7.5, or you can leave it in fractions. So the lateral area is 2 times pi times 15 over 2, and then the height of that, even though it's on its side, is still 32. So these will cancel. I'm going to do 15 times 32 in my calculator. And I got the lateral area is 480 pi centimeters squared. You can leave it like this if you'd like, or if you want to get a decimal, you can multiply by pi in your calculator. And I got the lateral area to be 1507.96 centimeters squared. So that is the label of the canned good. But if you want the surface area, then you're going to take that lateral area plus the area of the bases. So that is 480 pi, and then our bases are pi r squared, and we had 2 of them. So the surface area is 480 pi plus, and then pi, and then we had 15 over 2 squared plus pi 15 over 2 squared. Again, if you just want to do the decimals, it's 7.5. So 15 squared is 225, and 2 squared is 4. And then I still have this 480. And then 225 over 4 plus 225 over 4 is 450 over 4, which reduces to 225 over 2. So the surface area is 480 pi plus 225 over 2 pi. I guess I could turn this. I'm getting really crazy with the fractions. This would be 960 over 2, and 960 plus 225 is, the surface area is 1185 over 2 pi. Again, if you just want to do decimals, go for it. That would give you an answer of 1861.4, and my unit is centimeters squared. So either way, there. Ooh, it's a little messy. I gotta fix it. Sorry. So centimeters squared. And then again, if you'd rather, you could do it this way. Okay, so that is how to find the lateral area and surface area of a cylinder or a canned good. Let's do one more. See if you guys can try this on your own. Go ahead and pause the video right here if you'd like and see what you can do. Okay, so if you tried it on your own, go ahead and check your work with us. Otherwise, you can follow along with me. So lateral area, I guess I didn't really follow directions. The last one just said surface area, but I'm finding both. I needed the lateral area to get the surface area anyway. This one just asked for the lateral area, but for practice, and it's our last one, I'm going to find the surface area as well. So I'm going to go ahead and use that 2 pi r times height because it's quick. But if you want, you can do circumference and you can roll it out into a square, which is base times height, and do all of that. But I'm going to go ahead and start with this 2 pi r. They gave us the radius, which was nice. And the height is 10. Again, that canned good's on its side, but the height is still whatever connects the two bases, so watch out for those. So the lateral area would be 40 pi meters squared. I like leaving it in terms of pi because it's more accurate, but if you would like, you can round, and that will be 125.7 meters squared for the lateral area, lateral surface area. So that was quick. The surface area, gotta switch colors. This one's pretty. The surface area is just the lateral area plus the area of the bases, which again is pi r squared plus pi r squared, because there are 2. So the surface area is equal to that 40 pi from the lateral plus pi times 2 squared plus pi times 2 squared. 2 squared is 4. So we'll have 4 pi plus 4 pi plus 40 pi, which gives me a total of 48 pi meters squared. And again, if you would like to type that in your calculator, you can. You'll get about 150.8 meters squared. So this is how you can kind of find the area, surface area, how much material they're going to need for those canned goods. Let me know if you guys have any questions. An overview of today, we looked at surface areas of prisms and cylinders. We did a triangular prism and a rectangular or a square prism. Then we looked at cylinders, and their bases are circles. In your homework, you might see some different shapes as bases, maybe pentagon, maybe hexagon, maybe an octagon, some rectangles and circles and squares, maybe a triangle. So watch out for those different shapes, and I think that homework is not going to be today. All you have today is to turn in your notes. So the homework will be up later. Probably Thursday, I believe, is when the homework will post for this. So go ahead and just upload your notes and have a great day.